Section 4.2, Patterns and Linear Functions. Identify quantities in the picture that vary in response to other quantities. Describe each relationship. It says in the solve it, you identified variables whose value depends on the value of another variable. In a relationship between variables, the dependent variable changes in response to another variable. The independent variable. Values of the independent variable are called inputs. Values of the dependent variables are called outputs. The value of one variable may be uniquely determined by the value of another variable. Such relationships may be represented using tables, words, equations, sets of ordered pairs, and graphs. In problem 1, it says, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. Let's start off with our table. So if we're setting up our table, what we want to do is have our number of rectangles represent our x. So number of rectangles are going to be our x. And then our perimeter is going to be our y. And then our ordered pair is going to be our answer. Ordered pair. That's our x, y. So if we look at the very first picture, there's one rectangle. And if we're thinking of how we figure out the perimeter of our rectangle, we know it's 2 times the length plus 2 times the width. So 2 times the length, so 2 times 6 plus 2 times the width. The width here is 1. So we have x being 1, and when we have 12 plus 2, that's 14. In our second picture, there are 2 rectangles. So then we're doing 2 times the length, 2 times 6, plus 2 times the width. And the width this time is 1 plus 1, which is 2. So here we have 2, 16. And we have 3 rectangles. We have 2 times the length, which is 2 times 6, plus 2 times the width. And the width this time is 3. So we have 3, 18. And then our last picture, we have 4 rectangles. Our length still is 6, plus 2 times the width, 2 times 4. So this is going to be 4, 20. So there's our table. So in words, right, we're multiplying the number of rectangles in each figure by 2 to get the total length of the top and both sides of the combined figure. So then we're going to add 2 times 6, or 12, for the total length of the left and right sides of the combined figure to get each perimeter. How we would write that as an equation would be y is equal to 2x plus 12. And then our graph, we would take the coordinates that we just found and we would plot them. So we would make our y-axis up and down, and our x-axis left to right. We would label it. And because we're going up to 20, I'm going to actually label my axis in increments of 4. So I'm going to do 4, 8, 12, 16, and 20. And then my x-axis, I'm going to keep it as 1, 2, 3, and 4. So I'm going to plot those points. So 1, 14. We'll say it's right in between here. And then 2, 16. It's right here. 3, 18 is in between. And then 4, 20. So that's our graph. In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So let's set up our table. So we're going to have the number of triangles be our X. And we're going to have our perimeter be our Y. And then the coordinate XY is our ordered pair. So in the first one, we have one triangle. And then the perimeter is when we add up all the sides. So it would be 3 plus 3 plus 4. And there's one triangle. And that's going to wind up giving us the ordered pair 1 comma. And then 3 plus 3 is 6. 6 plus 4 is 10. Two triangles. We're going to have 3 plus 3 plus 4 times two triangles. And that ordered pair is 2 comma 6 plus 8 is 14. And then in the next picture, there are 3 triangles. So we're doing 3 plus 3 plus 4 times 3 triangles. And that ordered pair is going to be 3 comma 3 plus 3 is 6. 6 plus 12 is 18. And then our last one, 4 triangles, 3 plus 3 plus 4 times 4. And that's going to be 4 comma 22. So in words, right, the perimeter is going to be 6 plus 4 times the number of triangles. How we write that as an equation is that the perimeter is going to equal, and we can, instead of using our P for perimeter, we're going to use Y, right? Because that's what we called our perimeter. So our perimeter Y is equal to 6 plus 4 times the number of triangles. We call our triangles X. And then lastly, we need to graph it. So we're going to plot all those points. So let me see if I can squeeze it in. We'll say right here, this is our X. This is our Y. And because the values are larger, I'm actually going to, let's count maybe by 6. So I'm going to do 6, 12, 18, and then 24. And then I'm just going to do these in increments of 1. 1, 2, 3, 4. So 1, 10, we'll say is right about here. 2, 14, we'll say is right about here. 3, 18 is here. And then 4, 22, we'll say is right about here. Functions. You can describe the relationship in problem 1 by saying the perimeter is a function of the number of rectangles. A function is a relationship that pairs each input value with exactly one output value. You have seen that one way to represent a function is with a graph. A linear function is a function whose graph is a non-vertical line or part of a non-vertical line. In problem number 2, it says the table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So the amount of Y of memory left is uniquely determined by the number X of pictures you take. You can see that in the table above, where each input value of X corresponds to exactly one output value of Y. So Y is a function of X. To describe this relationship, let's look how Y changes for each change in X on the table. So we can see that when we go from here to here, it's going to go up 1. From here to here, it goes up 1. And then from here to here, it also goes up 1. Okay, so the independent variable X increases by 1 each time. And then when we look at our memory, we can see that it decreases by 3 each time, right? So the dependent variable Y decreases by 3 each time X increases by 1. So the amount of memory left on the chip is 512 minus the quantity 3 times the number of photos taken. So how we would write that is y is equal to 512 minus 3 times x. And it says we can actually draw this to verify like what we're saying. So if we created our XY axis, okay, and the numbers are really big. So how we show that there's like we're going to go, kind of large is you'll see in graphs like they're broken up with that squiggle line. And so we're going to say that this is 500 and I'm going to count by twos. So then this is 502, 504, 506, 508, 510, and 512. And then our x, we're still going to keep as like 1, 2, 3, and 4. And this is 0. So when we have none, no pictures taken, we start at our 512, right, which is right here. When we take one picture, it goes down to 509. So it's right here. When we take two pictures, it goes down to 506, which is here. When we take 3, it's going to go down to 503, which is right about here. Is the relationship in the table below a linear function? Describe the relationship using words, an equation, and a graph. So let's look at our input. So here we're shown that if we start out at 0 for our x, our output is going to be 8. We can see that our x's are increasing by 1, and that's pretty constant. So we know that our independent variable x is going to increase by 1 each time. When we look at our y's, we can see that they're going to increase by 2 each time as we go, and that's consistent too. So our dependent variable y increases by 2 each time x increases by 1. So how I would write that as an equation is I would say y is equal to, starts off at 8, and I'm going to add 2x to that, right, because it increased by 2. And we can verify this using our table. All right, so let's make this 0. Let's make this x. And let's make this our y. And I'm going to count by, I think maybe 4s this time. Let's do 4, 8, 12, 16. And then I'll count by 1s here. 1, 2, 3, 4. And 0, 8 is here. 1, 10 is here. 2, 12 is here. 3, 14 is here. Okay, so you can obviously see that if you connected these points, it would make a line. So therefore, it's linear. And it says, does the set of ordered pairs 0, 2, 1, 4, 3, 5, 1, 8 represent a linear function? Explain. So we can either look at our x's, right? And you can see that this difference would be 1. But when we do this difference, it's 2. And then when we do this, it actually goes down 2. So just by looking at our x's alone, I'm going to say it's not linear. We could even plot these points to visualize it, right? Let's say you're unsure. You can actually graph it and see if it creates a line or if it's all over the place. So let's make this 0. This is our y. This is our x. Let's count by 2s. Let's go 2, 4, 6, 8, and then we'll do this by 1s. 1, 2, 3, 4. So we have 0, 2, which is here. 1, 4, which is here. There's nothing for 2. 3, 5, which is here. And then 1, 8 which is there. So you can see that that very last point, and even 3, 5 doesn't line up with the first 2 points that we actually graphed. So I'm going to say this is not linear.